Memory based learning. In memory based learning, we mimic the way our brain recollects the information. To better understand what is memory based learning, let us take a small example of writing an exam. So when we are writing an exam, we will encounter a question which we do not know about this particular question. So now for this question, which answer we will write? So this depends upon the training we have done ourselves while we were preparing for this examination. So prior to the examination, we will be preparing some questions, that is for question 1, this is the answer 1, for question 2, this is the answer 2, and so on for question n, this is the answer n. So now when we encounter a question called Q test in our examination, which we have never seen before, so now what we will do, we will recollect all the question and answers which we have studied earlier to our examination, and we will write the answer for this Q test question as the answer, wherein the answer which is similar to this particular question. So which I mean is, let us say this Q test is similar to Q3, even though the values of this Q test are different from the values of the Q3, but if you find this Q test to be similar to Q3, so you will be recollecting the answer A3 from your brain, and you are going to answer the Q test question with the same answer as A3 with some changes in their values. So this is how a general memory based learning is going to work out. So in memory based learning, all of the past experiences are explicitly stored in large memory, which is having correctly classified input and output examples. So here if you see, these are the correctly classified questions and answers which were explicitly stored in our brain. So whenever we get a question which we do not see, now we compare this question with any of the questions which is similar in our stored memory, and then we will answer the question Q test with the answer which is similar to one of these answers. So we now see mathematically how memory based learning is being done. Let us say we have a vector called x bar, which is having the values x1, x2, x3 so on up to xn, and we also have the desired responses d bar. So these are the desired responses corresponding to the values in the input vector x bar, that is d1 is for x1, d2 is for x2, and so on dn is for xn. So for simplifying our discussion, let us take this d bar vector as a scalar, that is we take one value di for the corresponding xi bar vector. So now what we will do, we feed the system with a lot of input output pairs. So for a particular xi, this is a corresponding di value, that is for a particular input, this is the desired response. For this input, this is the desired response. For this input, this is the desired response. Let us take a small example of the binary pattern classification problem. So here let us take that we have two classes, that is class C1 and class C2. So if a particular input belongs to class C1, then di takes the value 0, or if a particular input belonging to class C2, then di takes the value 1. So let us see here how to represent this one. So let us say I have drawn a graph like this. So now the di value will be 0 for class C1. Let us say this is the class C1, and let us say this is the class C2. Okay, so these are the points in this space, and these are the points in this space. So for class C1, and this is class C2. So for class C1, we have, for the corresponding input values, we have the di value as 0, that is for this input value we have 0, for this input value we have 0, for this input value we have 0, for all the other input values we have 0. Coming to class C2, for this input values, for this input point we have class as, for this class C2 we have di value as 1, and for this input value we have the di value as 1, for this input value we have the di value as 1. So after representing these values for C1 and C2, now we have got a new test vector which is nothing but X test, which we have not seen before. So now our memory based learning algorithm responds by retrieving and analyzing the training data in the local neighborhood of X test. So let us say we have the point here, this is our X test which we have not seen before, and these are the other points which we have. So now whenever the system encounters the X test, the system responds by analyzing the training data which is in the local neighborhood of X test. So for this point X test, these are the local neighborhood point of X test. So the system analyzes all these values and the system assigns the value for the X test for which these values are having that particular class. Now let us say this point is xt bar. So this point is compared with all the inputs which we have fed in our system, and then we find the point which is closest to xt bar. Let us say we have some points here also, and some points here also, and some points here also. Now among all these points we find the point which is closest to this xt bar. So now let us say this point is the closest one to X test, that is this is X test, and this point is the closest point to X test. So if you remember, we already have the corresponding output for this point in our memory. So the output of this point will be taken as the output of X test. So this is how memory based learning is going to work. So if we see, all the memory based learning algorithms involve two essential ingredients. The first one is the criteria used for defining the local neighborhood of the test vector X test. So the algorithms are differentiated based upon the first one, the criteria which we use for defining the local neighborhood. So this is the X test. So different algorithms define different criteria for defining the local neighborhood. So based upon this point, the memory based algorithms are categorized. And the second point is based upon the learning rule applied to the training examples. So if you see, these are our training examples. So basing upon the learning rule applied to these training examples in the local neighborhood of X test. So now let us discuss about the one of the variations of the memory based learning called nearest neighbor rule. So what does the nearest neighbor rule specify? According to the nearest neighbor rule, the local neighborhood is defined as the training examples that lies in the immediate neighborhood of the test vector. So here this is our test vector. So this is our training example, and this is also another training example, and let us say we also have another training example here and here. So now the local neighborhood is defined as the training example that lies in the immediate neighborhood of this test vector. So let us say this is our test vector. So the local neighborhood is defined as the training example. This is our training example which lies immediate to the neighborhood of this particular test vector. So this is called nearest neighbor rule. So in particular, the vector xn bar, so which is having the points x1, x2, so on up to x capital N, is said to be the nearest neighbor of X test. The Euclidean distance between xn bar and X test bar is equal to minimum of the Euclidean distances between xi and X test. So here d of xi comma X test represents the Euclidean distance between the vectors xi and X test. So let us get to clarify this by using an example. So let us take a binary classifier as discussed before. So these are all the training samples or training inputs. So these points belong to class C2, that is this point belong to class C2, this point belong to class C2, and all these points belong to class C2. And now these points in this place, in this space, belong to class C1, that is this input point belongs to class C1 and this input point belong to class C1. So let us suppose that we have a test input here. If you see this point is the test input. So here we can say that the output of this particular input is also belonging to class C2. How are we saying that this test input's output is C2? The closest input to this test input, which is nothing but, let us say if this is the closest input to this test input, so the output of this closest input is C2. Okay, so that is the reason we are also telling the output of this test input is also C2. So this is how memory based learning is going to work out, basing upon the Euclidean distances, that is the distance must be the minimum Euclidean distance between the vectors xi bar and x test bar. We also have another variant of the nearest neighbor classifier, which is called as the k nearest neighbor classifier. The k nearest neighbor classifier proceeds as follows. First of all, it identifies the k classified patterns that lie nearest to the test vector x test for some integer k. And now, as a second process, this algorithm assigns the x test to the class that is most frequently represented in the k nearest neighbors to x test. So let us understand this with the help of an example. So if you see, these are the input points which belong to class 0. So if you see, these are the input points which belongs to class 0, and these are the input points which belong to class 1. So if you see the dashed circle, the area lying inside the dashed circle includes 2 points pertaining to class 1. So this is one point which pertains to class 1, and this is another point which pertains to class 1. And if you observe, we also have an outlier from the class 0. So if you see here, we have a point called 0 here, which is an outlier from the class 0. Now this point D corresponds to the test vector. If you see here, this is the point D which corresponds to the test vector. So now what does the k nearest neighbor classifier do? Now this k nearest neighbor classifier assigns class 1 to this test vector D. If you observe, even though this test vector D is nearer to this 0, but this k nearest neighbor classifier assigns the class 1 to this test vector D. So if you follow the memory based learning algorithm here, generally for this test input to D, the closest input point is this one, which is having a class 0. So the memory based learning algorithm will assign the output 0 for this x test. But this is the drawback of memory based learning algorithm. So this drawback has been eliminated by using the variation of nearest neighbor classifier, which is nothing but the k nearest neighbor classifier. So the k nearest neighbor classifier takes the values of all the nearest neighbors, not just a single neighbor, but it will take the values or corresponding outputs of all the nearest neighbors. That is, it takes the output of this nearest neighbor which is 1, and this takes the output of the nearest neighbor which is 1, and finally now the test vector is being allocated the value 1 but not 0. Even though it is the closest one, it is not allocated with the value 0. So this is how the k nearest neighbor classifier is going to work out. Thank you.